So, this is the diagram for the computer. It's I designed this all myself. So, if the clock here, which controls the CPU and all the timings and stuff, CPU would control the D-locks. There's D-latches. I'm not really sure. I kind of modified the design I found online to make it just so it locks it and stores it. The program is basically just the data which gets computed by the CPU. These are all registers. They're separate parts of the same thing. The opcodes, the operation codes, the program will control, and it just allows it just tells the CPU that this program wants this program. The RAM chooser, that is separate from these, but still a part of it. So with the program, that's loaded as well. It tells the CPU which RAM registers it should use for the select programs. I've made a new monitor design. I'll get to that in a bit. It would be 81 wires wired to the monitor. 81 here, 81 here. So when it releases this, when it releases the D-latch. Sorry, let me rephrase. You input the first opcode. This tells the CPU which program it should use initially. And then that will go through here, or well, a bunch of wires here, into the correct D-lock, which will release the selected program. The program will go into the CPU using the 81 wires. So all these being 9. That will go into the RAM and sort of repeat the same sorts of systems. Now, I kind of said so I kind of said stuff about not knowing how to do an actual monitor, and I got the terminology wrong. Well, from what I saw, there wasn't actually any sort of single wire data bus. That is a thing, but that's not really how monitors use. And I was actually quite close with my design, except I did it in a way where it could not, they couldn't touch. They had to have this one space. But I watched a MattBatWings video on YouTube, talking about monitors or displays. There was this 2x2 node which is fully stackable. So for the computer, I've now made a 9x9 monitor which can display each individual pixel like this, which is quite good. So I'm probably going to build the memory, and I'm going to build the RAM and ROM. Then once I've done that, the order doesn't really matter here, but I'll either do those two first, since they're fairly simple. It's just a bunch of different registers and D-locks. D-latches doesn't really matter. But I should probably work on the CPU, because that will define how the ROM works. So I probably will build CPU or RAM, ROM. I just got to figure out how to do it. I'm not going to use like I'm not going to use like a standard sort of CPU. I don't think. I might be wrong though. I'm going to use basically just a bunch of XORs. So it will take the data from the program and just compute it using all of those XORs, which is just going to make it, it's going to make it very similar to a cellular automaton rather than a standard computer. But that's okay. That's kind of what I wanted, because it would still be Turing complete, because it can loop back into itself, call other different programs and stuff like that. And I don't have to calculate the Y on the screen because I just flatten out this to a row. So then that's just a part of the same systems as I've been using for literally everything else. Now I've got to figure out a new design for the XORs because the current design I'm using is quite, well, it's probably bigger than it needs to be, realistically. So I go over to where I have all the logic gates. Obviously you got your OR, because this is an OR, is very, it's just pathetic, but that is technically it. Same with this, you just, but one is on and it's on. Okay, my current XOR, if you ignore all of this, it boils down to just this. It boils down to basically just that, which is probably bigger than I need it to be, because I'm sure there's a way that I could get it to probably fit within that sort of space, or like this, be much more efficient that way. So I'm gonna have a look online for that sort of stuff. Yeah, that was pretty much all I wanted to record. I actually have music off this time. But yeah, I've started work on the computer. Got the monitor. Yep. Explain everything. Also it would, so assuming 81 wires from, or around that, from the RAM going into the CPU here, not crossing with the inputs, then I would, when I mentioned the signal splitter, I just meant that I would intercept the signal here, so it would still continue, but also I would just transport it over here into the screen buffer, which is just another register, just, I don't know, for the monitor. It goes into here, there. There'd also be an extra input here or somewhere, which resets everything. So that might like activate the clock, reset the screen reset the screen buffer, and reset all the RAM. But obviously I could create an instruction to do that with the program, but it is also easier to have a manual reset. I could also create a quote-unquote bootloader, which sets up the opcode automatically based on a stored program value, or operation code. But that's not really necessary, it's fine to do it manually. It gives you like an actual reason this keypad needs to exist. It wouldn't this computer architecture doesn't allow for inputs to happen whilst the program's running. However, I could probably modify it to, but I don't think that's really necessary.